Hello, folks. Gonna get going in just a second. I'm gonna turn off my streams, say hello to some folks as they come in, then we'll get started here. How's everybody doing? Hi, Beata. Thanks for hanging out. It's almost a long weekend here in the US, so I am in extra Friday mode. I'm actually taking, we have Monday off as like a nation, and then I'm taking Tuesday off as well. Hi, X Micron. Thanks for stopping by, hanging out. I haven't looked at the ferry lines yet, but we're gonna go catch a ferry. Happy long weekend, Taya. Thanks for hanging out. I have the hover cam. It's hopefully working. This is gonna be a fun break for me. All right, let's get going. Hello, everybody. My name is Scott. I go by tannewt online. I work for Adafruit on CircuitPython, although I probably won't talk about CircuitPython at all today. If you don't know, CircuitPython is a version of Python designed for little tiny computers called microcontrollers. Here is a RP, let me switch to product showcase mode. An RP2040, this black chip here has a little tiny piece of silicon in it that has a kind of all you need for a computer all in one. This is a Qt Py board, so this is a nice small form factor that it was inspired by the Seed Studio Shao's and Adafruit, who I work for, and this is their YouTube channel, creates boards like this, for example. So they take other people's microcontrollers, put them on different boards of different shapes, and have different accessories with that, and sell that. So where I come in is I usually work on CircuitPython, which is a Python version for microcontrollers. It's based on MicroPython, and it is designed for, it's designed for Adafruit hardware. It's the software piece of the hardware puzzle, or the complement to the hardware piece. So that is that. I saw your question, Ty. I'll answer in just a second. So this is a deep dive. I usually do this 2 p.m. Pacific here on the Adafruit Discords on Fridays, not Discords. And if I'm unable to do it, usually Foamy Guy Tim will fill in for me. This is generally a 2-hour stream where it's just kind of what I've been working on, or what I want to work on in today's case. So I'm happy to answer questions as people ask them. And otherwise, the kind of topic I had in mind for today was actually more of the build stuff that I talked about last week, but applying it to, I think the last couple of weeks I've also talked about this project where these are boards that I've designed. Lamore did not design them, I did. But this chip in the middle here is also a microcontroller, but you can load code to it over I2C. So I've had this goal of pairing the two up together so you can actually have 2 cores doing stuff that you want, kind of as a complement to the main core. So I wanted to apply the build system stuff to that, and we'll talk about SVD files as well, which we'll get into that. But first, Tyeth asks, how's the BLE stuff come on this week? I got excited enough to start messing with the Bluefruit Connect library, getting the packets to flow over serial and web workflow. I got distracted by some other stuff this week and did not actually do any BLE. That's the honest bit. Lots of odds and ends. Lots of odds and ends that I didn't get to. Hi, Bruce. So yeah, good segue, Taya. Thank you. And I'm happy to go on tangents that people ask about. So feel free to bring any topics up that you'd like me to talk about. Otherwise, I'm kind of planning on doing this build system stuff. Healthy distractions are good. Yeah, it was good. It was good. It was just not BLE. And that's why I'm kind of like, I'm ready to do something that I want to do. And this G0 stuff. This microcontroller, Tyeth asks, what micro is on here? And this is the STM32G0. But since I actually started this project, they also released the C0. So let me go to the desktop. Okay, so here's the page for the G0 series, and it's the value line. And it's interesting, I've had my eye on this line for a long time because it actually has up to 144K of SRAM. So I had my eye on this G0 line for a while to replace the SAMD21. And the other reason that was interesting to me is that the non-value line has and it actually says the value line has it too, but it has USB device in it. I spent a lot of time looking at ST chips and see. But one thing that was interesting is so this is the package, a 32-pin LQFP or UFQFPN, ultra-fine quad flat pack something, 32-pin package. Can get the largest RAM sizes. So the 128K is too small for kind of like all of the code, but the 256 and the 512 versions would be able to run CircuitPython. So that's originally what caught my line with these G0 chips. Unfortunately, these ones are actually pretty pricey. The ones with lots of flash and RAM are actually quite expensive. The place that I'm living in this kind of stemma G0, I call it stemma G0, is I'm actually living in this 20-pin column. So I don't know exactly the part number. So they're pin compatible, so I was able to order these. I bought these fully assembled. Well, let's pull up Digikey. And we'll just do STM32G0. And we could look at the evaluation boards. I have... Those ones look weird. We want the MCU evaluation boards. I have some of these. They're not too bad. One thing you have to be aware of is these boards don't have the native USB broken out on them. So you have to be a little bit pickier. So this one's got 2 USB ports, one on each end. This one will break out the native USB. But not all of them do, so you gotta take a look at that. Oh, interesting. This is it. Oh, M5 Stack has a... What are they using it for? Analog to I2C unit. Interesting. So yeah, there's an ADC on here, and they're using it as a kind of like a dongle, kind of what I'm talking about. USB-C stuff. Oh, and interesting. Yeah, so they're using it for a cheap ADC expander. Hi, Zarnlin. Oh, and I should say hi to DJ Devon3 too. So if we go back and we actually want to look at the microcontrollers, and let's just go by RAM size. And I don't even know if they're in stock. We'll do by RAM size and price. And if you sort by price, it's at the real quantity, so $2.12 for a real of the 512K flash ones, which is not too bad. They don't have any in stock, which is another problem. I wonder if they have any in stock. So let's filter by that. I need to clean my mouse. Yeah, so the cheapest in singles is $4.12. Now, if we are comparing that to the CMD21, we'll do the same sort of calculation. I mean, it's a lot more RAM, but we want RAM size 32K, in stock, apply. So they're like under $4 in singles. I don't know how quickly it goes down. I'm actually surprised. This is higher than I thought it would be. So yeah, it has crossed my mind at some point. I think I would like to do CircuitPython for this line, just because it is interesting from that respect. And see, it's got this 32 QFN package. Let's see what, yeah. This is also a 32, this is the 32 LQFP, and then the 48 QFN. That one doesn't have enough flash. I spend a lot of time on Digikey. We've talked about this before. I look at new dev boards. I'm always interested in like what new dev boards, especially because ST subsidizes them, so they're like pretty cheap. Toilet says, I saw an issue with the ESP32C6 DevKit C when using web workflow. I put the Wi-Fi settings in a toml file at work, then took the controller home. Tried to change it from a different Wi-Fi and I could get to the repl. Was there a way to push the toml file via the serial connection? Yes, you can. I manually do it. I literally just like go into the repl. Oh, you know what? I have a better answer. If you're using Chrome, but you can go in the repl and you can do the like open the file name, writable, f.write, and then f.close. You can do it via the repl, or CircuitPython.org downloads will actually do it for you too, I think. So if you pick the one that you want, and then, oh, we don't have it enabled. Okay, so this is a problem. We should be able to do the installer as well, but it's not enabled on the website. But if you look at the C3, there's this open installer. What you can do is you can say open installer, and then, oh, this is Chrome. But you can, I don't think, usually it's not. So this is Chromium C3, shall open installer, and you can just click update Wi-Fi credentials, and that may work. I haven't tried it, but that should only do the file itself. Yeah, and Dan points out that code.circuitpython.org is being updated to work over the serial only link as well. Melissa's doing that work. So yeah, we're working on it. So one thing that's interesting to me is like, okay, let's take a look at the bottom end. I don't actually know what the Digikey pricing for the bottom end of this is. So like this, the STM32G0 F6P6, which is like near the bottom. One, they have like almost 100,000 in stock, which is kind of awesome. And the 20 TSOP is what my design's for, but it's $1.13 a piece for that. But if you're like me and have discovered JLCPCB assembly, which is awesome, because it's like, you get it all fully assembled. Hi, FedA2. Ty says it would probably work if you just use the C3 version to update the C6 via update Wi-Fi only. Yeah, definitely try it. It should be all the same. Just don't load the firmware. So now we're on JLC, and these are the parts that you can use in their assembly service. And they have a bunch in stock too, but you'll see here that like this, the 30 F6P6 off JLC is 49 cents in singles, which is awesome. And that's about as low as I've seen it. Their price sort never works well for me. I don't know why. But yeah, so what I did is I did a board design, which I do have public, I think. It's either under here, I don't see it under here, or yeah, so if you just do the plain stem of G0, the keycat files are here. Yeah, that's true. You have to factor in shipping and assembly costs, but I think I got, like, I don't know. Let me see if I can. Off screen, I'll log into my JLC and see what. See if I can show all up costs. It was quite reasonable, is what I think. Yeah, I spent $100. $100 plus $26. What all did I get? I got, okay. So it's the same board layout. But because, yeah, it's like $10 a piece. So I got 3 different, I think I did the same everything but the microcontroller. So 5 pieces of each for, so 15 of them for $100 plus $26 shipping. It's been pretty awesome. And then I took the Metro M7 and I changed it, and I got 5 of my modified versions of the Metro M7. I did it for this trace port on it. 5 versions of that was $104. $104 before $26 shipping again. So like, it's been great for me. I've done hand assembly before, and it's just magical to just get it to me directly. Anyway, so I also look at what parts are available here. They also came out with a C0 line, which is like pitched as a cost reduced version of the G0, but I haven't actually found it for cheaper. But they should be part compatible. And then I also have this. So what's cool is that STM chips have bootloaders in ROM, which means it's like quite hard to not be able to flash them. There's a few bits that control whether you can have access to it or not. But you can see here, like all these different series have I2C protocol for bootloading. So I was like, I had thought of this project, and then I was thinking I would have to make my own I2C bootloader, and to find that they already have a bootloader for it, it was quite cool. And I have some CircuitPython code, and I need to find it. But I was working on the code to load it. So what I wanted to work on today is, I was showing the build system for CircuitPython last time, and now I was in the weeds of how CircuitPython builds stuff and its complexity, and I actually wanted to kind of go to the other side and try to apply it to a super simple Blink example for the STM32G0s. And you'll notice also that so on these test boards, I also put the SWD connector on the back. So I don't actually need to use the I2C bootloader. I can use SWD to do that. Okay. So I just updated this. So now I should be able to run Python. Oh, I think I have to source it. Python build.py. And I don't have all the things installed. I don't have my dependencies for the build system set up. So what I'm working on is, usually when vendors give you, they'll have header files that have all of the registers kind of structured into all the information about the chip structured into C header files. I kind of wanted to reinvent that, so convert SVD data into C header files. So what is an SVD file? It's a system view description, if I remember right. And let me see if I can open one. Downloads. cmsis-svd. Okay, so here I've downloaded this pack for an SVD file, and I'm going to pick the G030. And for some reason, it opens XML files in Chrome. But this is what an SVD file looks like. So it says copyright Apache 2, which is great. It tells you what CPU it is, what revision, endianness, whether there's an MPU, how much priority shifting there is, blah, blah, blah. And then there's this big, long, turns out this peripherals thing is really long. So it says like, oh, this peripheral's at this address. Here's the base address. Here's the address block, so how big of a memory space that peripheral has, and then all of the registers that it has. So usually there's header files, and in fact, we could find in here they have pre-generated header files as well. So the equivalent is here. So here's like the generated version. So all the interrupts, and then they have like type definitions for different registers. So this is how you can write to. Fede2 asks, is this similar to a Linux device tree file? Kind of, yeah, kind of. Linux device tree files, you know, they are also capturing the structure of the system on chip, but more specifically for like the drivers of the drivers that are needed for all the individual bits of the chip. But yeah, kind of. It's giving a wider view of the chip than just the CPU itself. It's also encompassing all of the peripherals and all of the registers for the peripherals. And then it has, oh, they use pound defines for that. So lots of pound define stuff as well. Oh, and they use pound defines for that too. I was debating whether to do that this way or not. Yeah, I'm not a huge fan that it's XML, but there's already an existing Python library to import it. And I don't know if I've ever showed it in GDB, but it can actually be really helpful for just viewing the state. One thing I actually want to do that I haven't done yet is I actually want to generate Python classes for all of these as well. Because in CircuitPython we actually have memory map now, which is just a reading and writing of memory. You could actually create Python objects or classes for it. And going back to the STM32G0 stuff, we could actually do a Python class, pass in a way of accessing memory that is actually over I2C. And so you could like address peripherals on the I2C connected thing. No, I did not generate this myself, but I'm working on my own version. Because it's kind of, I don't know what this add to group exported constants thing is. I don't know what, I wanted more control over it, which shouldn't surprise you. So I'll be in the embedded build there too. But if I just do Python build.py. Okay, so this, one thing I'm using under the hood is cmsis or pack manager. And I think I can do STM32G. Let's pip install it. Oh, it's already installed. There we go. Huh. Okay, so I'm using another Python library that knows how to find information about parts. These are all ARM parts, but there is, if you go to, oh, my fingers aren't where I think they are. If you go to Espressif-svd, the system view description files, and they actually provide them for Espressif chips. And I thought it was interesting. They have the SVD file for the P4 that you can't even get yet. And they have two versions, one for the ULP and one for the regular one too. So it's like describing how to access all the peripherals, which is cool. So SVDs are getting more adoption even outside of ARM. And one of the reasons is this, all of the embedded Rust stuff is pretty much tied to it. They have this SVD to Rust generator. And so if you're wanting to do embedded Rust, you probably have an SVD file that is like your standard source of register definitions and stuff. Hi, Yaza. Okay, and then that, of course, well, this is the bootloader, not the datasheet. All right. All right, I timed out the person typing a bunch of M's. That is not helpful. Okay. So let's see if the build works. Ta-da! So this is all debug output. But if we pull up, oh, I didn't add folder to projects. Home, repos, STM32G0. So now I have a build directory and I have an I2C directory. So this is the version that I'm generating. And here's my build file that I'm doing. So right now I'm just saying, hey, find me an MCU for this string. Give me the first one, and it should only return one. And then I'm going to await generating a C header for the I2C. I2C regular should work too. And then all of this is, as I point to my screen, that's debug output. So this is the version that I've generated, and I was just working on this last night. So one thing I did, and this one doesn't do. So if we try to find I2C1, there's some stuff related to clocks, and there's stuff related to system configuration registers. all sorts of auto-generated stuff. So this is the type definition for the entire I2C, and they don't have the bit fields broken out of the individual registers. So what I'm doing here is I'm creating a struct for each individual register and adding, so basically doing bit fields for that too, which some SVD stuff will and some doesn't. I'm not sure exactly why. Some do it and some don't. And one thing I'm interested in is like I've been getting more into the like, you know, the more advanced tooling. Like I've fully fallen in love with having GitHub Copilot in my browser, in my IDE or in my text editor, or whatever you want to call it. It's really helpful for debug prints. Like I can start writing like np print and then it fills it all out. Are there rules or general conventions for the information for the SVD file? So it's publicly documented. It's turning into an open. There's this project on GitHub called Open-CMSIS pack, and there is a SVD spec. There's a directory, there's a link to it. Okay, so here you go. So system view description. There's this utility, but this utility I don't think is open source. It's available for Windows and Linux. It does some checks and stuff. It's a .exe. I don't think it's publicly sourced. But this is the thing that can be used to generate. Like that looks quite familiar, doesn't it? Here, field struct. But it's an anonymous struct. So I want to experiment with doing that slightly differently too. And then there's a definition for it here. So this is all like XML sorts of stuff. But you can like tell what processor it is. Apparently it doesn't tell you memory. I thought it said memory region, had memory regions in here as well. But they don't see it. So yeah, it's publicly documented, but the code for the generator is not. Who knows what it is? So I was like talking about GitHub Copilot. I was writing this code last night. It's awesome. Like starting to do like output.write, and then it based on the context, it like tries to guess what you're gonna do. It's not always correct, but it's like sometimes quite close. And then this is Clang. I was thinking I want to make sure that it's like Clang D clean. Like I want to lean into the Clang D tooling as well. So this is interesting because they do it as a pound define which means there's like no actual variable for it, but I think it would actually be better to have it as the second option here, because I think then it would allow you to, in the debugger, access it. So yeah, that's something that it will work. ClangD's just being a little weird about it. SVDConv. Oh, I saw that. Yeah, I did. I looked at it last night and it didn't look to me like it had enough like novel code. I got pretty close pretty quickly. I was curious because it does have it do the linker script, Oh yeah, so this is not using the cmsis-svd library. It's going straight from the XML. So yeah, I was referencing this a little bit, but and I was curious how it was doing the linker stuff, but it's still not clear to me how it's getting what it's putting in the linker. Okay, so what I'm going to do is I want to get this building. So I want to try to do, so I have this make file, and I think this is what I ran into, like, it was really annoying. So if I run the make file, hey, it worked. It didn't work on my laptop, and I'm not sure why. Probably because I have more stuff in here than what is in my actual. Okay, so in lib, I didn't realize that there was submodules in here. I wouldn't have gone quite down this rabbit hole if I had. Get modules. Oh, interesting. So I'm pulling it from cmsis device G0 and STM cube. I forgot about this. That's why it didn't work. I must have been doing it on this computer originally. I didn't think to update my submodules on my laptop. I wonder how up to date it is. 1.44. Let's see what they changed. They must have defined a few more bits. Like, all these changes are just auto-generated. cmsis version, release notes. Update to support USB supply enable feature for STM32G0 B0 devices. Fix the location of the .size directive in the startup code. I don't know. I don't need to do that. Well, that's kind of cool, though. Maybe I could do the thing I wanted to do is get to the point where, so the idea is that the device is a USB or I2C target. And if it's a target, then I can, what am I getting from? Oh, I have something in the submodules that I'm not using anymore. Okay, well, it builds now. So I just want to keep doing it the other way. Locate the main libraries. Do. Let's see if I can get the embedded build stuff working. Okay. So what I'm going to do is, now I'll just do await compiler. Do I want to use GCC? No, let's try doing it with Clang. See, it's making stuff up, and it's not right. I think what we have to do is we have to do embedded.compiler.Clang. Is that what it is? And then compiler.build. And we're not building the header file, we're building main.c. main.o. Let's look it up. Embedded compiler Clang. Okay, Clang should work. We're going to do compile. We're going to give it the CPU, the source file, the alpha file, and the flags that we want. So we're going to do the oh, see, I need mcu.cpu. We'll add that. And then flag-wise, I think we just want -i build. So we want to look for headers in the build directory. And we're going to await that. Where are my letters? Build is unknown. Oh, it's probably compile. That is where you can get thrown off. String object has no attribute parent. Okay, so this is a convenience thing where compiler.compile is assuming the output file is a pathlib. But what we could do is we could say if is instance close output file string, output file equals caller directory slash output file. And if is instance input or source file equals caller directory source file. This is warning me probably that I know it's not none. How do I tell it it's not none? I might have to figure that out. I know it's a pathlib. This decorator is capturing it for me. I do want to be build equals pathlib path build. Okay. See if that works. Permission denied. And open. That shouldn't be. That doesn't seem right. Oh, there's a double. Is it the double slash that's throwing me off? Build main O is not in the subpath of that. Resolve should, I think, make it. There we go. Okay, so now we're including a file that we can't find. Extra slash, thanks, Tyeth. Oh, this is even better than GitHub Copilot, is having people watch you on stream. Okay, so I want to switch it from this file on into the other one. Yeah, YouTube is on a slow delay so that it has the captioning. So hopefully the captioning is working. Otherwise it wouldn't be worth it. Okay, so we're not going to use this. Instead, it looks like we're doing Flash stuff. So I think what I'm going to do is I'm going to do include flash.h. And I'm actually going to do a second C generation. Now this is all in one after the other in sequence, but I can parallelize it in just a moment. Unknown type name. Okay, so the Flash generation didn't work. So we'll have to fix our source generation here. Browser live captioning, even translation is fantastic. Is that in Chrome? Or is that? I haven't heard of that. Microcontroller init. Generate C header. Let's take a look. Keybyte. Oh, here we go. This is something super silly. Super duper silly. So the SVD file has wrapping in its comments. And I undid it for there, but I didn't undo it. I undid it for the comments on the register fields, but not on the registers themselves. Which is super silly. Yeah, Chrome. Live translate, live caption. Wow. That's pretty cool. Maybe I don't need to worry about it. Okay, so I know what my problem is here. I have this if new line in description, then do this. And I just need to do it here as well. I'm in like write haphazard code mode. If you haven't known me in that mode before. So just hang in there if your brain's exploding a little bit. All right. So it still happened. So that one was fixed. Oh, but I'm only doing it there? Yeah, I'm not doing it here either. Have it twice. D. I probably could just overwrite it. Reading my Korean Netflix is the poorly captioned moments. That's a blast. Okay. All right. Interesting. So Clang complained that main should return int. There's a warn main return type. So this is one thing I need to think about. How do I want to structure fields that only have one, or one registers with one field? Probably just take the value straight in. Is that from the old days of return codes from executables? I don't know. I don't know. You can look up the -w main return type. And it's even suggesting, I wonder if I could just, in main.c. Oh, it's giving me a thing. Quick fix. Boom. Nice. Undeclared identifier flash. Oh, well, that would do it too. It's here. In your header. How is it undeclared? Can I do flash type? One thing I was thinking about was having it generate a separate C file for this part, because it's warning me to not do it there. Well, that's not the same warning. This warning is like, hey, you shouldn't do this in your header file. Yeah, maybe. So it is actually compiling. I just don't know. Oh, you know what it is? It's the compile commands, I think. So Clang D uses a database to know, so it can't find the flash thing. If I change this to build flash, it would work, I think. Yeah, see, it all goes away and it gives me the actual errors. This is something I've been meaning to add to the embedded build stuff, is that there's this compile commands JSON that Clang D can use to know how a file was compiled. I actually want to do opter and boot cell. Equals 0 equals false. So that should be equivalent. And then flash r to s1. Busy. Is that not in there? No member in the SR struct. What's it called here? Will you not tell me? Oh, come on. I don't know how to... SR... I thought it would give me nice... Busy. Ah, it's not, it doesn't have a 1 next to it. I don't know why there's a 1 next to it in this other version. And then this is the equivalent to op start equals 1. And then here's another busy check. So I think these should be equivalent. I hope they're equivalent, because that's what I'm doing. Okay, so these keys are weird. And then it looks like we've got some other stuff that we need to generate too. RCC is probably clocking. And then so this is code to just toggle a pin on and off, if you didn't realize it. That's my... That's what it's doing. Let's see how our build's doing. Okay, so I think probably what we want to do is if a field is, if a register is only a single field with a bit offset of 0, then we don't use a struct, we just do it directly. So like, if we look in Flash and we look at opt_key_r type. What is the clock speed? I think it's 64 megahertz. So there, it's got a register called opt_key_r in the, so like, it's not useful to have that extra field. So in here, instead of doing fields.sort, if length of fields is 1, and fields 0 dot bit offset see, it even added the second check that I was not planning on adding. Field description. Wow, it just generated this huge chunk for me, which is not that helpful. See, like, I don't know why it's giving me a whole bunch of stuff. I do wish there was a way to like accept a little bit of it. I might want to negate this. No, it's okay. Bit width equals r dot. It's making that up. Else. Okay, we want this comment to be shared, so I'm going to put it up above. I'm doing a little bit of weird stuff where the outer level aggregations get kind of stored in a list and output it at the end. That makes sense. So all we're going to do is we're going to do this instead. But instead of this, we'll just do a uint32. Bit width register dot size. Okay, let's try it. Control plus right arrow or just right arrow from some IDE clients to accept one word chunk at a time with a copilot suggestion. Oh, thank you. I don't know. Well, I'll have to try that in just a second if Sublime Text does that. So this is very clearly just that I'm like not generating it quite right. Like I'm still generating the struct part, which I don't want to be doing. This. Current offset. I do find it occasionally will be like trying to autocomplete right before I want to just indent stuff. So I inadvertently accept it. I thought I fixed this. Maybe I didn't. Did I not change that? Opt our boot cell. Okay. So what I think this is, if I remember right, is that there's a boot pin, but the boot pin, so thinking about the stemma G0 case, you load your code over I2C, something happens, it doesn't work, and then my plan is to have a command that can get it back into the bootloader that you can send over I2C, but if that doesn't work, how do you get back into it? And there's a boot button, but by default, the boot pin is not active, so this code here is saying like, hey, like, let's make sure the boot pin is always active when we're doing this sort of thing. Okay, so RCC GPIOB is what we also need as well to get this compiling. So let's go back to our build script, and we're just gonna add, I'm gonna add 2 more. And maybe what I'll do, it probably won't help too much because there is the run and thread thing. Maybe I should try that. I'm trying to figure out how to run them in parallel. Oh, and it guessed the right thing. Look at that. Isn't that insane? Let me put it actually in order because I'm pedantic like that. Okay, I generated it, but I did not include it. And I'll just do, maybe that's okay. I was thinking about calling it generated. Is that not what I called it? Oh, it's just not used. That must have been spurious. Redefinition. Oh, interesting. Okay. So RCC is failing. It's failing and it's, oh. Okay. Clock control register. CR. I don't know why we would be getting, oh. 2 peripherals have the same type. Okay, that makes sense. Okay, so I need to make it a little bit more specific. My struct names need to be not only the register name, but the peripheral group name. This code is like, maybe a candidate for like, factor all this out. I'm doing a lot of copying and pasting, which I shouldn't be doing, but. I think that's, did I get all the places? There we go. So if we look at Flash now, it should be Flash SR type, which makes this type a little bit weirder, but it makes it unique now. Let's see if the plus. No, right arrow doesn't work. Control right arrow? No. I could look it up. See if it does it. That would be nice. Okay. Okay, so let's fix these. I should delete these submodules too, because it's not going to work. It's going to require it. GPIB enable. Build. There can be a problem where it's called IOPB enable. IO port enable. Okay, so what did this end up being? Configuration bits. So it's just the number. Oh, this is interesting. Because I've parameterized it. But by parameterizing it, I can't access it raw. I wonder if I could add a .raw to it. So like for everything that has multiple fields, let's just try that. Let's do it manually and see what works. Oh, I don't think that'll work because I can't have an anonymous. It has to be a union of structs. How do I do that? Where's that parameterization that means you can no longer get raw access? No bit shifting and setting. I was trying to avoid it, but I hadn't thought about the case where I wanted to do it programmatically. I do wonder if it could be a notion of a repeated field, and if it's a repeated field, then I can detect it, and I can actually make this an array of 2 bits, so that you could like give the offset via the array. I don't know if that works. Can you do an array of 2 bits? An array of 2-bit values? I don't know if that works. Export it to the header in more than one format. I thought about that, yeah. Yes, I thought about that. Let's pull up the, let's see what we're working with as an input. Okay, so we're working it as an input with it being enumerated out. So we would have to detect that it was enumerated out and like unenumerate it. I guess what we could do is we could do a top level raw. We could do a top level raw. So what we would have is like we would duplicate, say we do this. And then we have like a raw. Or regs might be a little bit more. Okay, might be faster for me to just add this. I'm going to lose all this work immediately when I rerun the script again. But it's the first one, that's convenient. Does that make sense? Can I add a... Oh, there's no peripheral level. Oh. Like, you have to opt into it. That's all the same warning. So now it would be... Do it at the top level. Use of undeclared identifier. Oh, I ran build. What did the vendor do for that field? That's a good question. Well, the vendor doesn't do field position at all. Right, there's just going to be a dot. Yeah. Yeah, so their GPO IO type def is the equivalent to, yeah. You can see there that they have 2 copies of the AFR. And I'm not, oh yeah, my flash is going to be wrong. Opt R. I'm not adding reserve registers yet, I don't think. So I wonder if I should, if I'm going to generate 2 different types of structs, like should I have the non-named one called raw, or have the fields, or not have the fields? Okay, it shouldn't be too hard to add. I'm just going to go like this. Output right. Hi, Timon. And then raw registers. Reg comment. I thought I saw dual ways of access fields in the RP2040 SDK, maybe mixing up microprocessors or tricking. Yeah, so that's one of my other beefs, is that vendors do it slightly differently. So another benefit of DIYing it is that we get the same style across all of them. We're like no longer, I mean, I'm kind of like pro don't don't rely on vendor code, because I do so much cross-vendor stuff, which is maybe why I'm thinking about this too. For now, I'm just going to assume that the register is always 32 bits, which is not always right. And we need to do offset tracking too, because we're not putting... So the order of the fields in the structs matters. Oh, and we're not doing the... What are we doing with SVD files? Yes, we're auto-generating C header files. Although I do want to auto-generate Python classes too. I'm not going to end up doing that today, but I want to do auto-generation of Python classes so that you, from CircuitPython, if you have memory access, you can just look at all the fields and all that stuff. Okay, so we're also doing instances. Okay. Generating commands for GDB to access fields too, right? Yes, so GDB, there's already a thing that can do that. It's by B. Nahil, Cortex and debug. This is what you want. You do SVD load, and then you can access it from GDB. So that I've used that for years. So it's super handy. Although, you know, there were ways to do Python bindings in GDB, so that, which is what this uses. But I wonder if you could make it having auto-generated Python code from GDB to do stuff. I don't know. Redefinition with a different type. Oh, yeah. Should I call it regs instead? Maybe that's a better thing to call it. Instead of raw. Is the motivation to auto-port parts for larger chip families? I think my motivation for the SVD stuff is to have the embedded build infrastructure just work, like just give you the headers you need, instead of having to figure out how to source it. Like if you, like the cmsis pack stuff, the cmsis pack manager includes SVD files in it. That's what we're using to determine we're not using the SVD file in there, but we're using another file to determine the CPU that's in there. So this is more motivation of just like, in my build system, I want to just say I have this part, and it generates all of the stuff you need for you, right? So like in build.py, I'm saying like, hey, I have this MCU generate the C header for this peripheral to this file, and I can await it, and I should be getting, ooh, I'm close. I should be getting a trace.json, which I am definitely a fan of. Repos. I really like that it does that. Oh, interesting. Oh, you know what? It's yeah, interesting. The trace only does subcommands. That's why we're only seeing compile. We're not seeing the full thing. But you know what we could do is we could do a viztracer. Do I not have? I don't have viztracer installed. Viztracer. So viztracer, build.py. Okay, so it gave me another trace, and this time the trace is 84 megabytes. Oh my goodness. It's a much bigger trace. But this, so this is like a raw Python trace. So this is cool. This is another benefit of Python. So the default trace file is what only the shell commands you're running get captured in there. But this is the full async IO stack that viztracer sees. So you can see how long we spent in get MCUs from string, which is mostly cmsis pack manager decoding stuff. It looks like decoding a giant JSON file probably. And then you can see how long it's taking us to generate our headers. And you can see that it's 1, 2, 3, 4 serially. Now there's this trick that maybe we should just do. We got time. So Python async IO has a way of doing, it probably won't help. It has this like run and thread thing. Running in threads. Asynchronously run a function in a separate thread. It's primarily intended to be used to executing IO-bound functions and methods that would otherwise block the event loop. But I wonder if it would just be helpful to just like, in the same way that the build system has a primitive for async IO to thread. I mean, that's still pretty cool. You know, let's just do it. So in our embedded build init, we have this run command. I wonder if what we should do is we should just say we don't need the colors directory because we're not going to change our directory. We don't need a working directory, but a description would be cool. Run function. And we're going to say function. And then, yeah, let's even use the shared semaphore. That's the stuff where async IO gets pretty complicated in Python. Yeah, async IO is not. Yeah, I agree. It's not simple. I'm really liking it for this use. So async IO to thread. thread function. Result. And we could even I wonder if we could capture an exception. I got recommended to look at some wrapping libraries instead of using asyncio directly, but I haven't checked that out yet. Yeah, one thing, I'm explicitly targeting Python 3.12, which is the latest version of Python, and it has task groups. So I've been using task groups. We'll get to that in just a second. I wonder if we could, if description, I guess we just log the function. And there's not going to be standard out. And we don't actually even need to worry about, if it's going to throw an exception, it's fine if it just throws the exception. String function. Whatever that'll do. And let's have it return result. Okay, so now in our build, let's do a task group. Async with asyncio task group as TG. And now I do, I don't know what that is. It's tg.create task, I think. Is that, do we need to do that? I don't know. See what happens now. Oh, it viztracer did it again. So, because that was in my command line history, let's just load the result again and see if we can see a difference. 1, 2, 3, 4. It's running it immediately. I don't see a second thread, nor is it running it concurrently. I wonder if that's because we're eagerly evaluating it. Do we have an eager? Remember. Oh yeah. I wonder if it changes if we do this. So eager task factory makes it run immediately. It'd be cool if it ran. I guess it can't really run concurrently. You can pretend to. Parse device, generate C header. Am I calling the asyncio toThread. What does my... I was hoping it toThread would actually run in parallel, but that's not the... Well, it only has one entry. Oh, that's why. We're not calling our helper. We're still saying generate C header, whereas we want build run function. Huh. I wonder if we should hide it. And you know what? We could even hide it in a decorator. Should we do a decorator? So in generate C header, let's say at run in thread. Okay. And now we're going to say def run in thread function. So this is a little weird. That looks right. Oh, that's not quite right. We want to return await run function. I think that's right. Tricky. Ah, it crashed. Run in circles wrapper takes 0 positional arguments, but 3 were given. Oh, we gotta... what is it? Pause args. I think that's right. Coroutine object is not callable. I'm getting all mixed up. So we're returning a wrapper, run in thread. Do we just want wrapper? Oh, wait. Is that right? No. Darn. Coroutine object not callable. Let's look at our example again. Function. Ah. It's not an async. So what we would do is we would in our microcontroller class, this is a non-async function because it's not doing anything asynchronous. So it's fine. It's doing file I/O, which actually might benefit us. Oh, so close. None type. Self-function. How is the decorator applied again? So when you put a decorator, you get a function call. Like when it's constructing the class, I think it calls the function. I think that's how it works. So like if we print, say we're here, if we do a print mcu.generate C header and we don't call it, we should be able to I should probably delete. So it is running. It's printing the output, which I should turn off because it's now annoying. Interrupts. I'm going to do separately. I'm going to do a separate one for interrupts. Interrupts have their own complexity. Okay, I missed a print. There's one. I like being able to edit this. Okay, so it's getting a bound method run in thread. It's a wrapper of a microcontroller object. Let's see what this says. It says none object is. Some of them were running. Argument of type none cannot be assigned to a parameter coroutine. The answer is, I don't know either. I thought run in thread, the decorator, I think the decorator's right. And then but we're calling it immediately. How does two-thread work? Blocking I/O. Oh, star args, keyword args. Oh, okay. So our mistake is that we're calling it immediately. We need positional and named. It's a little ugly, but with the wrapper, it's not too bad. And then in here, we do we have to expand it out? Or do we not? I think that's right. Right, so we're capturing the arguments and then passing it to this thread thing. Value after star must be an iterable, not microcontroller. Run function. I thought this should... Oh. We don't need to expand them out at this point. There. Cool. And we're actually doing... Is there async IO file writing? Is that what we should actually be doing? I don't actually know. Maybe we should be an async function? And in that case, it would run them concurrently if we were doing an async Python async file, right? Most operating systems don't support asynchronous file operations. That's why async IO doesn't support them. Curio has it. Maybe Python doesn't. I wonder, well, let's look, we just ran it. Let's see if we actually get concurrency now. Because even, I bet we do. What is this error? Oh, this is just the compiler. Okay, so let's take a look at, this is why the speed scope thing is really nice. Oh, that's what this is. Our trace.json, the stuff that we output, still only has one entry. Why is that? It has a function generate C header. Like, that's not unhelpful. It's got more in it than what this is showing. Let's start it fresh. It might be on the wrong time scale. Come on. Huh. I don't know why it didn't. Four. Oh, this. Oh, you know what? I think I need to be on Perfetto. There we go. Okay. (16 milliseconds) while generate took 335. And then if we do the viztracer run of it, (83 megs). That was a lot more data. This is so helpful for a build system, I feel like. But obviously I'm biased. Get empties from string. Oh, look at that. How cool is that? So here we can at least see that. So this is interesting. We're parsing the device twice. And that's most of our time. So if we wanted to be more efficient about it, we would figure out how to, like, do it all in one pass. I guess we could do it as 2 stages. zlib decompress. Get device. If we simple q get. If we got the device and then gave it into that. Actually, I bet we could fix this. We have the device, get device. And let's just say self device is none. If self device is none, then we say self device is that. And where do we use device? Right here, self. Well, I didn't want to like have that cost up front, but now we've shared it. It's like tracing is like helpful to, let's see how it looks now. Okay, so there's the main thread. I should have compared times. 677. Oh. I think it's still a race condition. Because they're going in parallel now. So like, what I could do instead is I could just say, assume we're going to use it, get it on construction. We could have a semaphore or something. String without placeholders. Yeah. Never know when I'm going to want to add something. Any other questions? We're just about to the end of this here. Okay. That did feel quicker. But that could be an illusion. Okay, so here we get in view from string, and here's our get device. And then what we'll find is, yeah, our I don't know what this simple q get is. Like the blip to actually generate the C file is like quite short. Run eager. Oh, it's probably just wrapper. Build stem and G0. Compile. It's just like waiting for the compile to finish. Oh yeah, this is just a red herring, like the thread's going and it's waiting to see if there's anything else. There were still a few compiler warnings from build. How did they affect the output? So we're not, the build's not completely working. What we're doing is the build system doesn't know how to not do things again. So we're basically like inspecting and how the build's running up until the point that it fails. And because our like task groups are something new in 3.12, and what they do is they cancel all of the, if one thing fails, all of them get canceled and you're done. so the build script here is saying like, generate all the headers and then compile. So it's like one after the other. That's why we're not seeing the concurrency between the two. But what's happening is that this compile command is raising an exception. So when your compile fails, it prints out your information and then it raises an exception which is what this is here. Which you could turn on and off. And something that would be nice about that run function thing is that we could have it capture the exception and print it out instead. Yeah, there's a little bit more C code to fix. There's this BSRR register where I think we just want the raw version of it again. Because the mask is generated, so. So that should work. So the compile finishes just fine. And you can see that it completed. We're just still printing the MCU out, or there's one print left in there. Like we're printing the function and we're printing MCU. Let's try it. Accept it. Linker. Link. I don't think it's going to work, but let's just see what happens. Yeah. So this is where we would need to build picolibc. It had an error. Oh, it can't find a linker script. I'm like staring at the error and I'm not seeing it. So yeah, so kind of the next step for me is to generate the linker script. Have others generated linker scripts in SVD? The link that somebody posted earlier had that happening, but I don't see the memory information in the SVD file. But I know, so in the pack, in downloads, in this pack, so this is what the cmsis pack manager Python library is managing. And you can get the pdsc file. And if we open that up, so this is not the SVD file, but the pdsc file. And if we look for G030, we find the subfamily, and it has like flashing algorithms. It knows the datasheet and the reference manual. It actually knows like what generated header to use. It also knows the SVD file for that family. And then it has specific SKUs. And for the specific SKUs, it knows the addresses of main flash and SRAM and some data about it. So my plan was to, I don't think I can do it with SVD. I'd actually be curious to see if the Espressif SVD files have memory in them. Otherwise, my plan was to just basically supplement. So like it can have vendor stuff as well. Like it has all the peripherals. And if we go to the bottom, like, yeah, it's still in the peripherals tag. So it doesn't look like Espressif's, like SVD files don't have it, and it's annoying. So I don't think SVD files actually know memories, but these pdsc files do. And for Espressif chips, we could just, like, we could have a function that generates, like, you could just, like, yeah, have a function that tells you. Like the problem with, we can't capture flash space in microcontroller for ESPs anyway because it's externally defined. Like the flash size is externally defined. So yeah, there's not like one way to generate a linker script. And that's part of like the way that I'm starting to form on my brain about this build system is like, it's all the individual pieces, but you still have to pick the pieces you need. So like generating an Espressif linker script would be different than generating an ARM one potentially. But yeah, for the pdsc stuff, it's like, I'll just generate it based on that to start. See, like, it knows the start address and the size. It's gonna be super basic. If you've looked at Espressif's SVD files, they are not super basic. But it's all, they're actually generated by Python code, I think. Like there's the generate LD Python script, right? So like, if you move to a world where it's all Python, they could just provide a function that you call instead of providing a script that you call. And it could be asynchronous and it could be concurrent with this stuff. Of course, it has a lot of configuration settings and you'd have to manage that too, but I don't know, totally doable. All right. I think that's it for me. Actually, let me commit it first. Since I am going away for the week, and build and .py and main.c. And that's all I want to add. Compiles. But doesn't link. It's asking for my GPG password. I need to change that. It uses GPG to sign commits, but I can have one password do it. Push tannewt main. And add others. All right, it's all pushed. All right, let's change camera. Thank you all for joining me on this deep dive and letting me entertain myself with this new SVD Python build stuff. I'm like, the tracing is so helpful. Oh, you know what? We didn't look at the trace for sorry, I wanna just the build system generated trace. Hey, look at that. Function, 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 function. Compile, link. And then you can do the compiles in parallel too. And in fact, you could potentially like know what headers were needed, but yeah. Oh yeah, sorry. Desktop. Thanks, David. I was a little excited about it. So this is the build system generated trace where you see the 4 functions and then the compile gets kicked off. The build and the link. I don't actually know what this gap is here. I wonder. We could look at the full tracer. The much larger trace. Build STM32G0 is calling wrapper find source get module. Get module must be expensive. This is looking up the call stack to capture. Interesting. That's like 23 milliseconds. That's what's doing the caller, the capturing the directory of the caller, the caller's source path. So that if you call into the build system with just a string or a relative path, it's relative to the caller, not of that thing that you called into, or your working directory. Which is a little weird, and that's Honcho has this weirdness too, and that's kind of been my like, oh, when you call into it, that's what it should do. Anyway, all right. Thanks. Sorry that I forgot that. If you want to join me, I'm gone Monday, Tuesday, but the rest of the week and normally during the work week, I'm on the Discord server, which is the middle here. You can go to the URL adafru.it/discord. I think I should be able to stream next week as well. We'll see. Maybe I'll get around to BLE stuff. I know I was working on it, but this stuff has my attention too, and so we'll see. Also, if you want to support me in CircuitPython, you can go to adafruit.com, purchase hardware there. Thanks in advance to DCD, who usually takes timecodes. Thanks to Foamy Guy, who backs me up if I can't do it. Thank you all for hanging out. Yeah, and gotta go catch a ferry, and hopefully the line's not too bad. I'm going over to my dad's house, so having some family time. All right, have a great weekend, everybody. I will talk to you next week. And here's the weather. A little gray, a little blown out.